Have you ever looked up at the night sky and wondered what's really out there? Beyond the stars we can see, a vast, invisible universe exists, filled with mysteries that have puzzled humanity for centuries. One of the biggest puzzles is something called dark matter. We can't see it, we can't touch it, but scientists believe it makes up about 85% of all matter in the universe. Its gravity is the invisible glue holding galaxies together. Without it, stars, planets, and even we wouldn't exist as we do. For decades, the true nature of dark matter was one of the greatest challenges in science. But one brilliant and determined astrophysicist would change everything. Her name was Vera Rubin, and her story is not just about stars and galaxies, but about perseverance, curiosity, and shattering expectations. Vera Rubin was born in 1928, a time when science, especially fields like astronomy, was almost exclusively a man's world. But from a young age, Vera was captivated by the stars. She would lie awake at night, watching them trail across her bedroom window, mesmerized by their silent cosmic dance. Her father helped her build her first telescope and took her to amateur astronomy meetings. She was hooked. She knew, with absolute certainty, that she wanted to spend her life studying the universe. But the path wasn't easy. When she applied to Princeton's prestigious astronomy program, she was flatly rejected. The reason? They didn't accept women. Can you imagine? Being told your dream is impossible simply because of who you are. Vera didn't let this stop her. She enrolled at Cornell University, where she studied under renowned physicists like Philip Morrison and Richard Feynman. It was there she began to form the revolutionary ideas that would define her career. For her master's thesis, she made a bold claim. She suggested that galaxies weren't just randomly scattered across the universe, but were actually clumped together, rotating around some unknown central point. Her idea was met with skepticism, even dismissal. It was too radical, too different from the accepted theories of the time. One prominent astronomer even told her she was just plain wrong. It was a discouraging blow, but Vera's conviction was unshakable. She knew she was onto something. After earning her PhD from Georgetown University, she began working at the Carnegie Institution's Department of Terrestrial Magnetism. It was here, alongside her colleague Kent Ford, that she would conduct her groundbreaking research. They had access to a new, highly sensitive piece of equipment called a spectrograph, which could measure the speed of stars with incredible precision. Their plan was to study the rotation of spiral galaxies, starting with our closest neighbor, Andromeda. At the time, everyone expected that stars farther from the galactic center would move more slowly, just like the outer planets in our solar system move slower than the inner ones. It's basic Newtonian physics. The less gravitational pull from the central mass, the slower you orbit. Simple, right? It's what everyone thought. But what Vera Rubin found was anything but simple. Night after night, she and Kent Ford pointed their telescope at Andromeda, carefully measuring the speeds of stars at different distances from the center. As the data came in, a shocking picture emerged. The stars on the outer edges of the galaxy were moving just as fast as the stars near the center. This was impossible. It defied the laws of gravity as they were understood. For the galaxy to hold together with stars moving that fast, there had to be a tremendous amount of unseen mass, a huge, invisible halo of matter providing the extra gravitational pull. The results were so bizarre, so counterintuitive, that Vera initially thought their equipment was broken. They checked and rechecked their calculations, their instruments, everything. But the data was solid. They moved on to other galaxies, dozens of them, and every single time they found the same thing: flat rotation curves. The outer stars were all moving way too fast. There was no other explanation. There had to be an enormous amount of invisible matter in every galaxy. This wasn't just a minor anomaly. This was a fundamental crisis in cosmology. Vera Rubin's work provided the first direct observational evidence for the existence of dark matter. The idea of dark matter had been proposed decades earlier by an astronomer named Fritz Zwicky, but it was largely ignored by the scientific community. It was Vera's meticulous, undeniable data that forced everyone to take it seriously. She had peered into the galactic darkness and found something that would revolutionize our understanding of the cosmos. Her discovery was monumental. It meant that all the shining stars, planets, and gas clouds we see make up only a tiny fraction of the universe. The rest is a mysterious, invisible substance that governs the structure and evolution of everything. It's a humbling realization, isn't it? To know that we are adrift in a cosmic ocean dominated by something we can't even see. Vera Rubin's journey was as remarkable as her discovery. She navigated a field that was often unwelcoming to women, balancing her groundbreaking research with raising 4 children, all of whom also became scientists. She was a tireless advocate for women in science, constantly pushing for more opportunities and recognition for her female colleagues. She famously noted that she had to fight for the right to even use the main telescope at the Palomar Observatory, which for years had no women's restroom. She literally had to break down barriers to do her work. Despite the undeniable impact of her discovery, which is now a cornerstone of modern cosmology, Vera Rubin was never awarded the Nobel Prize. Many in the scientific community believe this was a major oversight, a reflection of the lingering biases she fought against her entire life. But Vera was never motivated by awards. She was driven by pure, unadulterated curiosity. In her own words, science is a collaborative and cumulative enterprise. It's not about one person. It's the joy of finding out something that no one knew before. Her legacy is not just the discovery of dark matter. It's in every young girl who looks up at the stars and dreams of being an astronomer. It's in the relentless pursuit of knowledge, even when the world tells you you're wrong. Vera Rubin taught us to question everything, to trust the data, and to have the courage to explore the unknown. She showed us that the universe is far stranger and more wonderful than we can imagine, and that its greatest secrets are waiting to be uncovered by those who are brave enough to look. So the next time you gaze at the Milky Way, remember Vera Rubin. Remember the invisible halo of dark matter that holds our galaxy together, a mystery she brought into the light. And remember that the quest for knowledge has no boundaries, and the universe belongs to everyone who dares to wonder. Thanks for watching. If you were inspired by Vera Rubin's story, hit that like button and subscribe for more tales of scientific discovery. See you next time.